Hey guys, it's Mrs. Diskevich. I just want to go through with you really quick. Before we really begin nomenclature, we need to take a quick review over remembering those charges and how to figure out the charges using the periodic table. So let's take a look really quick at the periodic table. So if you recall, we have basically an S block, which is the first two columns here, the alkaline earth metals. And then essentially we have this P block, which is a lot of our nonmetals, our metalloids, and a few metals in there. But basically, through here, we can tell these are referred to as our representative elements. So with our representative elements, we are able to determine a lot just using the periodic table, which we can't always do that with these transition metals here in the middle or the inner transition metals. We can, however, predict many things just using the position of the representative elements on the periodic table. So quickly, I just want to go through and just recall that this first column here has one valence electron, the second column, two valence electrons, and then we come over here to the third column, everything in this row or column has 3 in column 13. Then we have 4 valence electrons, 5, 6, 7, and 8. And remember to have 8 valence electrons. This is very stable. And this is our goal because we are trying to fill the octet rule. So if you recall then, knowing this, we're going to have to determine what our charges could potentially be. So in order to do that, we can, let's take a look at this one. We can determine the charges based on the fact that, hey, we have one valence electron here. So therefore, to get 8, it's going to be easier to lose 1 instead of gain 7. So therefore, if we lose 1, these typically become a +1 charge, everything in this row. The alkaline earth metals, they have 2 valence electrons. So therefore, it's easier to lose 2 than to gain 6. So they're going to be a 2 plus. Staying with our representative elements, here we have 3 valence electrons. It's going to be easier to lose 3 than to gain 5. This one here with the carbon, typically, we could do 4 plus or 4 minus, but most of the time these are not going to ionize. Only in strange conditions will they. Now here we have nitrogen, and it has 5 valence electrons. So now we're at the point where it's easier to gain than it is to lose. So if we have 5 valence electrons and we're filling the octet rule, we're going to gain 3. Oxygen, these have 6 valence electrons, which will gain 2. Fluorine has 7 valence electrons, which will gain 1. Remember, these will not ionize. So we will not make ions using noble gases. So let's just do a quick recap. What is the charge then of sodium? So find sodium on the periodic table. We see sodium here as 1 valence electron, so it's likely to lose an electron. So that charge is going to be a 1 plus. We have phosphorus. Phosphorus is over here. It has 5 valence electrons, so it's likely to gain 3. Fluorine. Fluorine's here on the periodic table. Has 7 valence electrons, likely to gain 1. Magnesium over here by sodium has 2 valence electrons, so it's likely to lose 2. And aluminum here has 3 valence electrons, so it's likely to lose 3. So hopefully this is just a quick recap of how to use this on your periodic table. This will serve utmost wonderful importance for you when you do ionic compounds. All right, take care, guys.